Hello, I'm Ed Freeman, and I've been doing data science since the mid-90s. Our field has had a bunch of name changes, machine learning, data mining, but the fundamentals don't change. Today, I want to talk about the difference between doing a successful paper and a successful project. So the first thing, and I've talked about this in other videos, is complexity. Papers need to be as complex as possible. That's what gets you published. Projects need to be as simple as possible to actually make it work. The second thing is data exploration. EDA per se isn't really part of papers. Papers, you're presenting a technique. But if I'm going to do a project, EDA is critical for a whole bunch of reasons. First off, you can get insights about the business that you don't get otherwise. Second off, you've got the issue of, are we actually doing the right project for the organization? Third off, it helps you a ton with your actual project work. For instance, there was a project I was working on for a client in our company. They'd given us the data set. The modeling was going awfully. I come in, do some histograms, and I find out that a quarter of the data is clearly junk, as in like negative values when it should be positive. So you need to do that stuff. And lastly, once you get an answer, you want to understand the answer. You've got a model, great overall metrics. Is there a group that is being unfairly treated by the model? You have to understand your answer. Third issue, a kind of a data set memorization in our field. A good example is movie lens. Because there are really so few public data sets around, what happens is the field gets optimized around these few data sets. If your data is not like a data set, the answers that are generated typically, techniques that are used without thinking, won't work for you. Now, I think this is going to get worse as time goes on. For instance, my company, we've talked about putting out a data set publicly to let people optimize on our data and not somebody else's. But there are huge privacy issues, especially with GDPR. And I think it's going to be a real problem going forwards of people kind of optimizing the field around a few data sets. The last thing, and this is kind of really inside baseball, it's a bit weird, is the metrics. Typically for papers and for classes, you're looking at confusion matrices. Confusion matrices are really only worthwhile if you're looking at a 50-50 yes-no split, or some kind of really balanced split in the variable you're predicting. If I'm going to actually doing a project for a business, I'm not going to just care about the yes-no, but how solid are my solid answers? How acceptably weak are my weakly positive answers? Now, so summing things up a bit, I want to talk about the uses of papers. Papers are useful if you're doing projects for a company. One thing, it's kind of a paradox. Topics are only actually useful once they're stopped being papers. What happens is that if people have a good idea, then they take the good idea and fold it into the software tools. So then it becomes trivial, and that's when it's useful. A good example of this is transfer learning. It used to be pretty brutal when it started off of having to hand hack model files. Now it's just a couple of parameters in code. And now there's a big lesson here. If you're trying to learn how to do data science projects purely from reading data science papers, it might work out, but you're going to have a pretty rough time. You actually have to research, if you're in this field, how to do the projects, not just the papers. So that's what I've got for today. Talk to you again soon. Bye.